Hello students, I am Nandita N. Nair from GSI PU College, Mysuru. Today I will help you understand chemical kinetics from a competitive point of view for CET. Okay, so let's start. So the topic, like I said, we are going to deal with chemical kinetics. Chemical kinetics is about rate of chemical reactions. Alright, so before I start off with the questions, I wanted to give you a quick roundup about the different concepts involved. So we'll be talking about the rate of reactions. So in the rate of reactions, rate of a reaction is equal to change in concentration by the time taken. So delta of concentration by delta T. This is average rate if you talk in terms of delta, meaning to say a large time interval, whereas if it is d of concentration by dt, that will be instantaneous rate for a very small time interval. Now if I consider reaction R getting converted to products, R is the reactant and P is the product. Now minus d of R by dt, when I say minus, that is because the concentration of the reactant decreases with time, whereas for product it is plus d of P by dt, meaning to say the product increases with time, the concentration of product increases with time. Now if you notice there's a square bracket, that square bracket means molar concentration. So molar concentration of reactant and molar concentration of the product, meaning moles per liter. Now if I have coefficients in the equation, AA plus BB giving CC plus DD. If you are having coefficients, please mind it, if it is negative it's for reactant, whatever coefficient you have to write as a reciprocal. So minus 1 by A dA by dt is equal to minus 1 by B dB by dt is equal to plus, because C is the product, so plus 1 by C dC by dt, which is equal to plus 1 by D dd by dt. Okay, now all of these are the ways you can represent the rate of a reaction. In terms of reactant it is negative, in terms of product it will be positive, so keep that in mind while doing the problems. Alright, and one additional thing, the unit of rate. The unit of rate is concentration by time, so moles per liter divided by time. The time could be in seconds or minutes or hours depending on the question. The next point is rate law expression. Okay, so the rate law expression tells you how the rate is dependent on the concentration of the reactant. So we have rate is equal to K into reactant concentration raised to the power of N. The N here is the order of the reaction. So K is the rate constant, also known as the specific reaction rate, and N is the order of the reaction. N can be 0, 1, 2, 3, etc. Now the unit of rate constant, very important point, so be alert about it. The unit of rate constant, concentration raised to 1 minus N, where N is the order, and time inverse. Now remember, concentration is molarity, so molarity means moles per liter, so mole liter inverse raised to 1 minus N into time inverse. So by looking at the unit of rate constant, we can actually predict what the order of the reaction would be. Now moving on to some graphs. I have the first set of graphs, which is rate versus concentration graphs. So in the rate versus concentration graphs, rate against concentration for zero order will be like this, rate against concentration for first order will be like this, and rate against concentration square, that is for second order, will be in this particular way. Memorize the graphs because it will be easy to identify it then. So moving on, we have now the concentration versus time graphs. So A is the concentration of your reactant, I will consider it as A. So A against time for a zero order will be this way, log A against time for a first order reaction will be in this way, 1 by A against time for second order will be a positive slope. So please remember these graphs. And then next one that we have is half-life period. Half-life period indicated as T half. So T half versus A naught. A naught is the initial concentration of the reactant. So if you are plotting T half against A naught, for zero order reaction will be directly proportional, so your graph will be this way. T half is independent of A naught for a first order reaction, so it does not change, it is straight. And you have T half against 1 by A naught. So if it is 1 by A naught, that is for a second order reaction. So here are some important formulae in order to remember the rate constant indicated by K and T half, that is the half-life period. For zero order, K is equal to A naught minus A by T, whereas T half is A naught by 2K. For first order reaction, K is equal to 2.303 by T log A naught by A. And here T half is independent of initial concentration, which is why it is 0.693 by K. For second order reaction, K is equal to 1 by T, 1 by A minus 1 by A naught, and here T half is equal to 1 by A naught into K. Please remind yourself that A naught is the initial concentration of the reactant and A is the concentration left by time T or left after time T. For first order reactions, this is a very, very important concept. Try and understand it before we start doing the problems. Imagine that we are starting with 100% of the reactant, okay? In the first T half, in the first half-life period, it gets converted to 50%. So, the 100% will become 50%. Now, in the second T half, it does not become 0, it becomes 50% of this. It becomes half of this, which means how much will be left? 25% will be left. Again, the third T half will be 50% of 25. So, that will become 12.5, and in the fourth T half it will become 6.25% and so on. So, one easy way to do problems is for 50% of the reaction to be complete. Remember, 50% of the reaction will be completed in one half-life period and the amount left will be 50%. Whereas, if you want the reaction to be 75% completed, then it will require 2 T halves, 2 half-life periods, and 2 half-life periods will result in 25% of the reactant left behind. The third situation, understand, if you have 87.5% completed, 87.5% of the reaction completed means how much is going to be left? 12.5%. In how much time? 3 T halves or 3 half-life periods, and like that it goes on. So, if you can remember these values, that is 50%, 75%, 87.5%, 93.75%, you will have an idea how much is going to be left behind. Okay. The last few points to remember in the synopsis is, one is the effect of temperature and the other is the effect of catalyst. In the effect of temperature, remember that for every 10 degree rise in temperature, the rate of the reaction will double. Means if the 10 degree decrease in temperature, then the rate will become half also. So, likewise. Then, in finding out the effect of temperature, one very important equation is there, that's the Arrhenius equation. And Arrhenius equation relates K, which is the rate constant, with activation energy, which is EA. Right. So, K is equal to A into E raised to minus EA by RT. A is called the Arrhenius factor. If you take it in the log term, you will have log K is equal to log A minus EA by 2.303 RT. In order to compare two rate constants, log K2 by K1 is equal to EA divided by 2.303 R, 1 by T1 minus 1 by T2. T1 will be the lower temperature and T2 will be the higher temperature. So, this is regarding the effect of temperature. And the very last thing, effect of catalyst. The catalyst, if I am talking about a positive catalyst, the activation energy decreases. So, if the activation energy decreases, the rate of the reaction would increase. Remember, there will not be any change in the value of delta H, that is enthalpy, and the equilibrium constant K. Please note that this is capital K is for equilibrium constant, whereas small k is being used for rate constant. So, now that the synopsis is done, we will move on to the questions. You have the questions in front of you, so have a look at that. The first question there, it says, in Haber's process, which is N2 plus 3H2 giving 2NH3, the rate of reaction was measured as 2.5 into 10 to the power minus 4 mole liter inverse second inverse. The rate of the reaction expressed in terms of hydrogen will be. That's what the answer you have to find out. Now, out of all the 4 options given, remember the rate of the reaction, whether you express in terms of nitrogen or hydrogen or ammonia, the rate of the reaction would remain the same. So, if the rate of the reaction given in the question is 2.5 into 10 to the power minus 4, whether it is in terms of hydrogen or nitrogen or ammonia, the value would be the same. So, among the given options, option B is the correct answer. So, that's for the first question. Now, remember the second one. Let me go to the second question. So, some questions I will be writing on the screen and showing you. The others I will be telling you theoretically. Okay. So, the second question says, for a reaction half A giving 2B, the rate of disappearance of A is related to the rate of appearance of B by which expression? So, I will write it once again for you. So, half A is going to get converted into 2B. So, remember, if you are doing in terms of the reactant, it will be minus and 1 by the coefficient. So, minus 1 by half into dA by dt, which is equal to, if it is in terms of products, it will be plus 1 by 2, because that is the coefficient, dB by dt. So, having done it like this 1 by 2 Okay, we'll go on the other side, and therefore your value will be minus dA by dt, minus dA by dt. This will become 1 by 4 dB by dt, dB by dt, because this half will be taken on the other side. Okay, so therefore your answer will be minus dA by dt is equal to 1 by 4 dB by dt. Option C. Option C for the second question. Moving on to the third question. Moving on to the third question. The third question is like this. The rate of a reaction is expressed in many ways. So the expression of the rate is given. Plus 1 by 2 dC by dt is equal to minus 1 by 3 dd by dt equal to plus 1 by 4 dA by dt equal to minus dB by dt. Remember again, minus is for the reactant and plus is for the product. So if it is given minus, those are your reactants and the others are your products. So minus 1 by 3 dd by dt, and I have minus dB by dt. So immediately you should know that this is question number 3. This is B is one of the reactant, and the reason I'm having minus 1 by 3 dd by dt means there are 3 moles of D. The coefficient of D will be 3. Giving. Now look at the product side. Product side, it says 1 by 2 dC by dt. So the coefficient for C will be 2 and the coefficient for A will be 4. So you will have 4A plus 2C. 4A plus 2C. So this will be the solution for your third question. Now let's move on to the fourth one. The question is kind of long. A reaction is represented by A giving B with the rate constant K1, and it's mentioned slow, and A plus B giving C, which is the fast reaction. Okay, so the first rate constant is K1, the second rate constant is K2, where K1 and K2 are the rate constants of the mechanistic steps. The rate of production of C will be, so rate of production means rate of the reaction. So rate of production of C will be. Now for this you have to keep one point in mind. So the fourth question, any complex reaction having more than one step, your slowest step is called the rate determining step. Your slowest step is called the rate determining step. So as mentioned, the first step is the slowest step. If the first step is the slowest step, then rate will be equal to K, which is your rate constant of that step. Of that step means K1. And there's only one reactant in that step, so K1 into A. So rate is equal to K1 into A. Option B is the correct answer. Now, question number 5. Moving on to question number 5. The rate constant K for the reaction 2x plus y giving products was found to be 3.58 into 10 to the power minus 4 liter mole inverse second inverse after 15 seconds, and it is 3.6 into 10 to the power minus 4 liter mole inverse second inverse after 30 seconds, and 3.56 into 10 to the power minus 4 liter mole inverse second inverse after 50 seconds. Hence the order of the reaction is. That's the question. Okay. Here the question, again a lot of values and all are there, but the key point is you have to check out the unit of K. So looking at the unit of K, you can see that the unit of K is liter mole inverse second inverse. Right? Now I have already given it to you that the unit of rate constant is generally written as concentration 1 minus n time inverse. So if you are having n as the order, and looking at this we can easily see that this implies that is 1 minus n is equal to minus 1. 1 minus n is equal to minus 1, because this is the unit for concentration, right? So it will become 1 minus n is equal to minus 1, which means n is equal to 2. So therefore looking at the unit of the rate constant, we should understand that the order of the reaction is 2. So that's your fifth question. Sixth question. For the reaction of the type A plus B giving products, it is observed that doubling the concentration of A causes the reaction rate to be 4 times as great, but doubling the amount of B does not affect the rate. What is the rate equation? So rate equation will always depend on which reactant concentration is going to affect the rate. Okay. So question number 6. Question number 6. It says that doubling the concentration of A causes the reaction rate to be 4 times. From this we understand that rate is directly proportional to concentration of A raised to 2. Because then we double the concentration of A, the rate has become 4 times. So that tells you that rate is directly proportional to the concentration of A raised to 2. The amount of B or doubling the amount of B does not affect the rate. Does not affect the rate means it will be B raised to 0. So it does not affect the rate. The concentration of B does not affect the rate, which means that term will not be there. So rate is equal to K into A square. A square. That will be the solution for question number 6. Option C. Then 7th one is a theoretical question. When hydrogen and chlorine reacts in the presence of sunlight to form HCl, the order of the reaction is dash. So here the clue point that you need to remember is that sunlight. Most photochemical reactions are zero order reactions. Therefore, you can pick option C, that is the order of the reaction is 0. The keyword, underline the keyword sunlight. Okay. Next, question number 8. For the reaction 2N2O5 giving 4NO2 plus O2, rate and rate constants are given 1.02 into 10 to the power minus 4 and 3.4 into 10 to the power minus 5 second inverse respectively. Then the concentration of N2O5 at the time will be. This is the question. They have not mentioned anywhere what is the order of the reaction, but you have to figure it out by looking at the unit of the rate constant. So looking at the unit of rate constant, which is second inverse. So second inverse means the order of the reaction was first order. How come? Because if you have, so this is question number 8, if you have concentration raised to 1 minus n time inverse, remember if n is equal to 1, this term will not be there and therefore K will have units of time inverse. So looking at that, here the unit of rate constant is given second inverse. Therefore we understand that it is a first order reaction. Knowing that it is a first order reaction, rate is equal to K into concentration of the reactant, which is N2O5 raised to 1. Rate is given, K is given. So how much is the rate? The rate is 1.02 into 10 to the power minus 4. So the rate is 1.02 into 10 to the power minus 4, whereas the K value is 3.4 into 10 to the power minus 5. So 3.4 into 10 to the power minus 5. Then you have to calculate N2O5. Then you just have to calculate N2O5. So the concentration of N2O5 is equal to, you have to divide 1.02 into 10 to the power minus 4 by 3.4 into 10 to the power minus 5. This will come out to be 3 moles per liter. 3 moles per liter. Remind yourself again that the square bracket simply means molar concentration, that is moles per liter. So option B is the answer. Next one, 9th one. 9th one again is a theoretical question. The hydrolysis of ethyl acetate CH3COET plus H2O giving CH3COH plus ETOH. So here these are 2 examples. There are 2 examples that you have to remember for pseudo first order reactions. If water is one of the reactants, then it becomes a pseudo first order reaction and this is one of it. So the hydrolysis of ni ester has to be considered as a first order reaction, pseudo first order reaction. So option A. Question number 10. In question number 10, again, unit of rate constant. So the unit of rate constant for a zero order reaction is being asked. So reminding you once again, so I'm moving on to question number 10. So reminding you once again, this is how you have the general unit for K. So the general unit for K is concentration raised to 1 minus n time inverse, where n is the order. In the question it is given that n is equal to 0. So if n is equal to 0, the unit of K will be concentration time inverse. So concentration time inverse means mole liter inverse, and it can be second inverse or minute inverse depending on the option. So here I have mole liter inverse, second inverse. Mole liter inverse, second inverse. So answer is option C. Answer is option C. So the next question is the 11th one. The rate of the reaction A plus B giving products is given by the equation. This is the rate law expression. R is equal to K into concentration of A into concentration of B. If B is taken in large excess, that's the keyword, underline large excess. If B is taken in large excess, the order of the reaction will be. So when B is taken in large excess, the change in its concentration will be almost constant. So as a result, we will not consider B in the rate law expression. So what will happen? This will be question number 11. The rate is equal to K into concentration, K rate is equal to K into concentration of A, because B does not come into the rate law expression because it is an excess. So this is like a pseudo first order reaction again. Okay. Next, question number 12. Question number 12. There was in the synopsis, there was one explanation that I had given you regarding for a first order reaction. 100% becomes 50%, 50% then becomes 25%. That one, you have to go look at that again. 75% of a first order reaction was completed in 32 minutes. When was 50% of the reaction completed? I said 75% completed is in 2 T halves. In 2 T halves. So in 2 half-life periods, 75% will be completed. So 2 T halves given in the question is 32 minutes. So 1 T half would be, if 2 T halves is equal to 32 minutes, then 1 T half will be 16 minutes. So in how much time will 50% of the reaction be completed? 50% of the reaction will be completed in 16 minutes. So answer is option C. Moving on, question number 13. The conversion of A giving B follows second order kinetics. They have told you that in question number 13, the reaction is a second order reaction. Doubling the concentration of A will increase the rate of formation of B by a factor of. So here writing a second order rate expression, it will be 13th question, it will be rate is directly proportional to concentration of A raised to 2, having been given that it is already a second order reaction. So if it's a second order reaction, then doubling the concentration of A. So if I double the concentration of A, what will happen? 2A the whole raised to 2. 2A the whole raised to 2. So this will be rate 2. So compared to rate 1, this will be rate 2 divided by rate 1. So A square will get cancelled. So 2 square, which means 4. So the rate of the reaction will increase 4 times. So on doubling the concentration of A, rate increases 4 times. Option D. Next is the 14th one. Half-life of a chemical reaction at a particular concentration is 50 minutes. When the concentration of the reactant is doubled, the half-life becomes 100 minutes. What is the order of the reaction? Okay. So the data given is that on doubling the concentration of the reactant, the T half also becomes double. Now let us see a general situation. T half of any reaction is directly proportional to A naught raised to 1 minus n. Which means for zero order, what will happen? T half is directly proportional to A naught because n is 0. For first order reaction, T half will be raised to 1 minus 1, which is independent. So T half does not depend on A naught. And for second order, this will be 1 minus 2, so it will become minus 1. So T half will be inversely proportional to A naught. So looking at the data given in the question, the T half becomes double when the concentration also becomes double, which means T half is directly proportional to A naught. When A naught doubles, the T half also doubles. Implies that this is a zero order reaction. So the order of the reaction, question number 14, the order of the reaction is 0. Option A. Next one, the 15th one. Half-life period of a first order reaction is 15 minutes. How much reaction will be completed in 30 minutes? This is like the reverse of question number 12, right? So have a look at question number 15. It says one half-life period is 15 minutes and they have given you 30 minutes and how much of the reaction will be completed. So if one half-life is 15 minutes, 30 minutes will be 2 half-lives. So if 2 half-lives are there in question number 15, you should remember 2 T halves. 2 T halves implies how much of the reaction will be completed? 75% of the reaction will be completed. Go refer the chart that has been taught in the synopsis. So this will be option A. So that's question number 15. Question number 16. rate of a first order reaction was found to be 0.69 into 10 to the power minus 2 moles per minute at the initial concentration of 0.2 moles per liter. Half-life of the reaction will be. So in the question it has been specified that it is a first order reaction. So let us start with the first order reaction. So since it is given as a first order reaction, I am going to write rate is equal to K into concentration of the reactant, okay, reactant raised to 1. So concentration of the reactant raised to 1. Now they want us to find the T half. So in order to find the T half, rate is equal to 0.693 by T half, because remember the value of K for a first order reaction in terms of T half is equal to 0.693 by T half into concentration of the reactant. So how much is the rate given? The rate given is 0.69 into 10 to the power minus 2, and the initial concentration given is 0.2. The initial concentration given is 0.2 moles per liter. So you just have to calculate T half. So you cross multiply, and if you calculate T half, this comes out to be 20 minutes. This will come out to be 20 minutes. But you have to be mindful of the fact that rate given to you is moles per minute. So the answer that I am getting is 20 minutes, but such an option is not there. So then convert it into seconds and find out your correct answer. So I will multiply into 60 in order to convert it into seconds. Therefore, your answer among the given options is 1200 seconds. Option D. Option D. Ready? Now, moving on. Question number 17. The rate of a reaction between A and B increases by a factor of 100 when the concentration of A is increased tenfold. What is the order of reaction with respect to A? This is the question number 17. Again, let me write here. So this is question number 17. Rate is equal to, we will take the rate of reaction between A and B with respect to A. They just want the rate with respect to A. So question number 17, rate is equal to K into concentration of A. I do not know how much is the order. So I will simply write it as N. So let me say this is rate 1. This is the initial concentration A1. This is the initial concentration A1. It says that the rate has increased by a factor of 100, which means rate 2 can be written as 100 times rate 1. 100 times rate 1 is equal to K will remain constant, and that happened when the concentration of A has been increased tenfold. So 10 times of initial concentration, 10 A1 whole raised to N. If you take rate, this is equation 1, let me call this equation 1, let me call this equation 2. So if you do 2 by 1, if you take 2 by 1, rate 1 will get cancelled. So you will have 100 is equal to 10 to the power N. 100 is equal to 10 to the power N. This obviously means N is equal to 2. N is equal to 2. So the order of the reaction for question number 17 is 2. So option D is your answer. Question number 18. The formation of gas at the surface of tungsten due to adsorption is a reaction of order dash. Again a theoretical question. Just like I mentioned earlier, photochemical reactions are zero order reactions. Similarly, surface reactions are also mostly zero order reactions. So you can go and take the answer 0. Therefore option A. Question number 18 is option A. Moving on, we have question number 19 there. The rate of a first order reaction is 2 into 10 to the power minus 2 mole liter inverse second inverse at 0.2 molar concentration. The half-life of the reaction is. So half-life of the reaction, and in the question they have mentioned to find it out in seconds. So this is how we have to do the 19th one. It is similar. We have already done a problem like that. So this is the 19th one. The rate is equal to K into concentration of reactant. Into K into is equal to K into concentration of reactant. The rate given to you is 2 into 10 to the power minus 2. Now since they require us to calculate the T half, let us write K as 0.693 by T half into concentration of the reactant, which is given 0.2 molar concentration. So again cross multiply, and what will you get as the answer of T half? So the answer you will get is 6.93 seconds. 6.93 seconds. Now will you get the answer directly in seconds? How do you check that out? Look at the unit of rate. The unit of rate is mole liter inverse second inverse. So the answer would directly be in seconds itself. So you get the answer option D. Option D. Now moving on, 20th question. For a first order reaction, A giving products, the concentration of A changes from 0.1 molar to 0.025 molar in 40 minutes. The rate of the reaction with concentration of A 0.01 molar is. So you have to find the rate of the reaction when the concentration of A is 0.01 molar. Okay. So with the given information, let's see how to proceed. It's a first order reaction. So in question number 20, let us say I am starting from 0.1 molar. Yeah. So 0.1 molar will become half, which is sir idon solpa illinde. Okay. So the 20th question. For a first order reaction, A giving products, the concentration of A changes from 0.1 molar to 0.025 molar in 40 minutes. What is the rate of the reaction when the concentration of A is 0.01 molar is the question. Yeah. So again, being a first order reaction, I am going to do it in that, how much is getting converted in what time that we will use. So let's say I started with 0.1 molar. For it to become half, means 0.05 molar. For 0.05 molar to become half, 0.025 molar. Have a look at what's given also. 0.1 molar has converted to 0.025 molar. Now this, as you can see, is the first T half and this is the second T half. So in two T halves, 0.1 molar gets converted to 0.025 molar, and this took 40 minutes. The question says this happened in 40 minutes, which means 40 minutes is equal to 2 T halves. 40 minutes is equal to 2 T halves. Therefore, what is 1 T half? 1 T half will be 20 minutes. 1 T half would be 20 minutes. That's the first information we get. Now they want to know the rate of the reaction. They want to get the rate of the reaction when the concentration of A is 0.01 molar. So what do? We write rate of a first order reaction. Rate is equal to K into concentration of A. So how will we write K 0.693 by 20? 0.693 by 20, because it is 20 minutes, we just now got it. So 0.693 by 20, concentration is 0.01. 0.01, and this comes out to be 3.467 into 10 to the power minus 4. 3.467 into 10 to the power minus 4. And check out the unit, it will be moles per minute. Moles per minute, because this is 20 minutes that we have substituted here. So you will get the answer in moles per minute. Option B. Option B. Question 21. 75% of a first order reaction is completed in 30 minutes. What is the time required for 93.75% of the reaction in minutes to be completed? I have told you before also, you have to remember 50% completed, 75% completed, 87.5% completed and 93.75% completed. That will become very, very easy for you to do the calculation then. Let me remind you once again. So 100 will become 50 in one T half. 50 will become 25% in the second T half or 2 T half. 25 will become 12.5 in 3 T half. And 12.5 will become 6.25. How much will be left? Will be 6.25 if there are 4 T halves. Correct? So going from here to, see, 75%, it says 75% is completed in 30 minutes. So 100 to 25 means 75% has been completed. So if 75% is completed, that means 2 T halves. 75% is completed in 2 T halves, and that is given to be 30 minutes. And that is given to be 30 minutes. Now they want you to find out how much time it will take for 93.75. Remember, 100 was the starting and 6.25 is the amount left, which means 93.75% is completed. As you can see, 93.75% means 40 halves. 40 halves. So if 2 t halves is 30 minutes, 40 halves would be 60 minutes. 60 minutes. So the answer for question number 21 is 60 minutes, option A. Option A. Question number 22. For the reaction A plus B giving C, it is found that doubling the concentration of A increases the rate by 4 times and doubling the concentration of B doubles the reaction rate. What is the overall order of the reaction? So question number 22, it's given that the rate doubles when the concentration of B is doubled, but the rate becomes 4 times when the concentration of A is doubled. So from here we understand the rate is directly proportional to A raised to 2, because when you double A, the concentration increases 4 times, whereas if you double the concentration of B, the rate also doubles. So this is the rate law expression. So the order with respect to A is 2 and the order with respect to B is 1. So what happens to the overall order? Sum of the 2 individual orders. So the overall order will be equal to 3. Will be equal to 3. So answer for question number 22 is option C. Now 23rd question. Interesting one, because it's like a reverse of what we've been doing so far. So 23rd question. Please go through the question. It says a radioactive isotope has a half-life of 10 days. So radioactivity follows first order kinetics, okay? A radioactive isotope has a half-life of 10 days. If today 125 milligrams is left over, so right now you are having 125 milligrams with you. What was its original weight 40 days earlier? So what was the original amount 40 days prior to today? Okay, so when it says that T half is equal to 10 days, which means 40 days is how many T halves? It's 4 T halves. So 4 half-life periods have been completed. And I'm now starting from what I have left. So 125 milligrams. 125 milligram is what we have today. We have to find out how much was originally present 40 days earlier. So this 125 milligram came from 250 milligram in 1 T half, correct? Now this 250 came from 500 milligram in another T half, and this came from 1000 and that came from 2000 milligrams in a course of 4 T halves. So in a course of 4 half-life periods, 125 milligram was left, which means how much did we start with? We started with 2000 milligrams, or we can say it as 2 grams. Therefore, answer is option A. Answer is option A for question number 23. Now question number 24. It is regarding the effect of temperature. A chemical reaction was carried out at 300 Kelvin and 280 Kelvin. So the temperature has decreased with rate constants K1 and K2 respectively. So I think this is a very theoretical question. Remember, I said for every 10 degree rise, the rate doubles. So which means for every 10 degree decrease, the rate will become half. Here, the temperature has decreased from 300 Kelvin to 280 Kelvin. So it has decreased 10 degrees twice. It has decreased 10 degrees twice. So question number 24, it was 300, it became 290, and from 290 it became 280 Kelvin, correct? So let us say this was the initial rate. So at 290 it will be half of it, so 0.5, and then it will be now 0.25. So rate constant is just an indication of the rate of a reaction. So if the initial rate constant is K, then now you will have 0.25 K1. 0.25 K1. So this is your answer, option C, K2, which means the rate constant now, K2 is equal to 0.25 K1. Question number 24. Moving on, again a different way of putting it. The temperature coefficient, question number 25 says, the temperature coefficient for the reaction rate of a reaction is 2. It means what I said earlier, for every 10 degree rise in temperature, the rate doubles. If I say temperature coefficient is 3, that means for every 10 degree, the rate constant triples. Here it is saying the reaction rate is 2. Now, the rate decrease if we decrease the temperature from 400 Kelvin to 320 Kelvin. So, kind of in the similar way. So, question number 25. Question number 25. We have started from 400. We have started from 400 Kelvin to 320 Kelvin. 320 Kelvin. Which means there were like how many 10 degrees decrease? There were 8 10 degree decrease. So, therefore, the rate of the reaction will decrease 2 to the power 8 times. 2 to the power 8 times. So, how much will the rate of decrease if we decrease the temperature from 400 to 320? Remember, from 400 to 320, 8 10 degrees are decreased. Therefore, we can take it as 2 to the power 8. So, option C. Same way, now it's an increased question. 26. The rate of a reaction becomes double for every 10 degree rise in temperature, as I already mentioned. If the temperature is raised by 50 degrees, then the rate of the reaction increases by about. I don't think I even have to write it. If you have understood this question, when the decrease is 10 degrees, it is 2 to the power 8. So, if the increase is 50 degrees, then we will take 2 to the power 5. So, how much does it change or increase? It is 2 to the power 5, because 50 degree means 5 times 10 degrees. So, 2 raised to 5, 32 times. Option C. 27 is just like that. So, I think you can do it by yourself. The 27th question also says the same thing. The temperatures increase from 30 to 100 degrees Celsius. Do it for practice by yourself. You can check out the answer. I am sure if you understood the first two, you will get this as well. Now, moving on, the 28th question. The rate of a reaction doubles when the temperature changes from 300 Kelvin to 310 Kelvin. What is the activation energy for the reaction? Now, when you have two different temperatures and when they are asking for activation energy, we have to move on to Arrhenius equation. So, what is your Arrhenius equation? If you are going to compare two rate constants, so question number 28 ke liye. So, in question number 28, we are going to write the Arrhenius equation in order to compare two rate constants at two different temperatures. So, this will be EA by 2.303 R 1 by T1 minus 1 by T2. 1 by T2. Got it? So, here it says the rate of a reaction doubles. So, rate of a reaction doubles means I can write K2 as 2 times K1. So, instead of writing K2, I will write 2 times K1. So, K1 and K1 will get cancelled, is equal to EA, which is our target. We have to find out the value of EA into, it's given in the question that you have to take R is equal to 8.314. So, remember 8.314 means it is in terms of joules. So, 8.314, what's your initial temperature? Your initial temperature is 300 minus 310. 1 by 310. So, this is your substituted equation, and only unknown quantity is EA, because K1 and K1 got cancelled. Log 2 is given in the question also. So, log 2 is 0.3010 is equal to EA by 2.303 into 8.314, 300 into 310, and this will be of course 10. Calculating this, you will get the value of EA. You will get the value of EA. The value of EA that you will be getting is 53,598 joules. So, remember this is in joules, but the options given are in kilojoules. So, 53,598 joules can be taken as 53.6 kilojoules. Option B. Option B. 53.6 kilojoules. Question number 29. The activation energy for a reaction is 9 kilocalories per mole. What is the increase in rate constant when temperatures increase from 298 Kelvin to 308 Kelvin? So, question number 29 has the same Arrhenius formula to follow. So, this is the same formula that you are going to have for question number 29. You are required to find out how much the rate has increased, which means I have to find out K2 in terms of K1. Alright. Now, the small difference here in this question is that the activation energy is given in kilocalories. So, the R value that you have to substitute should also be in calories. So, 9 into 10 to the power 3, because it is in kilocalories. So, I convert to calories. 2.303 into, what is the R value in terms of calories? The R value in terms of calories is 1.987. We can round it off to 2. So we take it as 2. So remember, R is equal to 2 calories Kelvin inverse mole inverse. That is one point you have to keep in mind. Into 1 by, the temperatures mentioned are 298 and 308. 308. 308. Okay. So here there is one issue, that is you will be actually getting log of K2 by K1. K2 by K1. So log of K2 by K1 will be given to you, and that this calculation comes out to be 0.212. This calculation comes out to be 0.212. Antilogs for all of these problems will be given in the question itself. So K2 by K1 is equal to antilog of 0.212, antilog of 0.212, which turns out to be 1.63. It will be given as part of the question, so don't worry about it. So K2 by K1 is antilog of 0.212, which turns out to be 1.63. So how much has it increased? K2 is equal to 1.63 K1. So the increase is 0.63. The increase is 0.63. So the activation energy given, the increase in rate constant is how much? So the increase in rate constant will be 63%. The increase in rate constant will be 63%. Option B. And the last question, 30th question. For a reaction, activation energy is equal to 0 and the rate constant K is equal to 3.2 into 10 to the power 6 second inverse at 300 Kelvin. What is the value of rate constant at 310 Kelvin? That's the last question. So what is the value of rate constant at 310 Kelvin? Same equation again, Arrhenius equation. So question number 30, Arrhenius equation. It is given that the activation energy is 0. So if the activation energy is 0, the whole term on my right hand side will become equal to 0. So if that becomes 0, log K2 by K1 should be equal to 0. Right? What value has log equal to 0? 1. So from here we understand that K2 by K1 is equal to 1, or K2 and K1 will have the same value. So therefore the K2 will also be 3.2 into 10 to the power 6. So that wraps up our CET session on chemical kinetics. Thank you.